That's kind of a double acronym. It stands for VISR atmospheric sounder, and VISR stands for Visible and Infrared Spin Scan Radiometer. This was on the SMS GOES series, and it provided the geosynchronous imaging of the Earth at half-hour intervals. And Suomi was always looking for an opportunity to take something that already existed and find a way to do something new and innovative and scientifically useful with it. And the VISR was basically the framework to provide a new capability. And he proposed in 1969 the idea of making this imager do double duty as also a temperature and moisture sounder. Now, this was a nice way of introducing this concept into the system, because it didn't take an awful lot to make it happen, and it had built on an existing system that was working very well. And it had the advantage, the geosynchronous altitude had the advantage of giving a view of the changing temperature of structure and moisture structure from a vantage point where the Earth stood still, as you heard before, and the atmosphere moved. But it's a little difficult doing this from high altitude. The geosynchronous orbiting altitude is about 22,000 miles above the Earth, and a regular weather satellite, or a polar orbiting satellite, is about 600 miles. So everything you're trying to measure looks a lot smaller from that greater distance. And there's less energy to measure, so it's a little more of a challenge. Now, VAS was conceived as sort of a combination of an operational and experimental capability, sort of following along the trail of developing the original spin scan radiometer. That is, you add something, it's a minor thing, but it makes a big impact. The VAS modification was designed to maintain that original operational capability of providing global images every 30 minutes, but using multiple infrared detectors and filter wheels sequenced in such a way that you would actually sneak in these extra observations without really interfering with the normal imaging sequence. And then under special circumstances, you could do what's called dwell sounding, where you give up the full imaging of the Earth and focus on a particularly interesting meteorological event. And the work that we originally did at Space Science was to try to flesh out this idea with specific instrument designs, specific choices of filters, what kinds of lenses and detectors would be used, what kind of performance we could expect out of them, and show that it would achieve the accuracy that was necessary to really invert these radiance measurements into actual atmospheric temperatures. Following this work of Bill Smith, we paid a lot of attention to what he was doing and what requirements he needed to get his polar orbiting work to be successful, and we tried to achieve that sort of performance from geosynchronous orbit. And I think it was in, 1972, NASA was finally convinced to proceed with the development of the VAS instrument. And this led to the design study by Santa Barbara, and there was a working group that was set up with NASA, NOAA, and UW involved. And Suomi and I and others were constantly going to Santa Barbara Research Center and reviewing what it was that the instrument performance was like, and fine-tuning the design. And eventually this final design was established in 1974, and that institute, at that point there was a VAS demonstration program instituted as well, and that's when I kind of lost contact with the program and started focusing more on other planetary systems. But Space Science continued to work with that. I think that may have been where we started developing the forest of antennas on the top of the building to help with the dissemination of data from the VAS system. And that flew on, let's see, there was an 80, 81, and 83 launch, and UW participated in the evaluation of the VAS system after launch, ingesting and analyzing and distributed the VAS data. And that phase of the program is something that Bill would be much better at describing than I am. Do you have anything to add about the demonstration program?
Well, only that Suomi was capitalizing on the successes in the polar orbiting sounding program, but really understood that the real value of atmospheric sounding was for predicting severe weather, tornadic storms and hurricanes and things like that. And to do that in a timely fashion, you had to do it from a geostationary satellite. So he had the vision for the very important weather application, where the polar orbiters were more for global, larger scale prediction. His vision was to use this concept for severe weather prediction. And in typical Suomi style, he came up with a way, as Larry said, of doing it, sneaking it in, so to speak, into an existing system. So it was doable and cost effective at the same time. And actually that, together with Makaitis, which was under rapid development at that time for support of the FIGI program, which Don just talked about, and the GARP data systems tests, which was the forerunner of GARP, led to developments in Makaitis, which made us realize in Washington, where I was at the time, that Makaitis was an essential tool for making use of the VAS data, the geostationary data, not only to process the data, but also to quality control the data and get the data to the forecasters in real time in a form that they could understand it, see it, not in terms of numbers, but in terms of pictures showing where the severe weather was going to take place. And so that's what brought the government group, which I led, back to Madison, is to develop a ground system that was really based on Makaitis. And of course, we were working with the atmospheric sounding processing capability for the polar orbiters in Washington. So that was, and the rest of it is somewhat history. It's been very successful. It led to, I think someone pointed out, the congressional hearing that was held here that got Makaitis in the National Severe Storms Forecast Center, and all the improvements in geostationary satellite applications that exist today.
Yeah, I can chime in a little bit on that. I was here in '68, '69, and worked on some of the very early studies, but that was purely a Suomi concept, as far as I can recall. I don't think it came in really from any of his travels. It was taken off from what Bill is doing with the polar orbiters and Dave Wark and others. And that it took a while. There were many skeptics, trying to do it from 40,000 kilometers or 22,000 miles. And again, Suomi would talk about the analogy of trying to take a drink out of a fire hydrant, and because so much data would be pouring down, people would say, how are you going to use it? Well, Makaitis was coming along. There were ways being demonstrated to use it. So I left Wisconsin in 1970, and I had my regrets. When you leave I went to Colorado State University. You can't take everything with you. You'd like to. I bet Bill had that feeling too. But I had to leave that one alone. And Larry and others came on, and it became very successful. So one day, here I am in the late 70s. I'm visiting the National Severe Storms Center in Kansas City, Missouri. And there I see a Makaitis with geostationary satellite data coming in. Severe storm forecasters are glued to that in the early morning hours, watching to see if the moisture will change along with the way that it had been forecast. And so that was one of the very rewarding things to see that technology, that idea that that were born here at Wisconsin, was being out there being used. And I don't know how long you directly, I know some of the UW guys would actually go to Kansas City, put improvements of software and things like that into that.
Fred Mosier, I think, was.
Yeah, Fred
Kansas
Mosier,
City
that's right, one of the students.
Fred had a direct pipeline into us.
Yeah.
A lot of times in more ways than I appreciated, but anyway, it was all for the betterment of the nation, I guess.
So we had a similar effort with the Hurricane Center, the National Hurricane Center. Right. And we got Makaitis down there, and would communicate with them daily on what they were seeing on Makaitis, and from the GOES-VAS data in terms of what it meant for hurricane strengthening and trajectory forecasting and so on.
That's right.
And that relationship is still very strong today.
Still going on.
Yeah.
In fact, the satellites that NOAA flies today still carry the sounders. And so here you go, concept in '69, here we are, 2009, another Suomi innovation, with a lot of help from his friends. He'd be the first to admit, lots of others involved, but really attributable to Vern.
Anyone who wants to come to the Space Science Engineering Center immediately walks into the building, and there's a great big display above the elevators. And the most beautiful images that are presented on there, as far as I'm concerned, are the family or the mosaic of geosynchronous satellite information on both clouds and water vapor to see this turbulent atmosphere. You see hurricanes, you see motion in the tropics, you see baroclinic waves, you see polar. It's all there. And that's because of things that were developed here in the Space Science Center.
He had an expression for that. He used to always beat me about the head and shoulders about turning data into information. Data was no good until you made information out of it. Very true.
One of the things that I personally have been most proud of having had a finger in this was that we gave it all away. I know there were certain people who said, oh, you should patent Mercatus. You should patent the software. It will return a great deal of money to the university. And Suomi was dead set against that. And of course, I was against it, everybody else was too. We gave it to everybody. I remember when Nixon went over and opened up a little dialogue with China for the first time, and then there was a little announcement in the paper that the Chinese had decided to reopen their embassy in Washington. I had a trip, I was going into Washington anyway, and Vern says, well, why don't you stop by the embassy and see if you can make contact? So I said, well, why don't you write a letter inviting the Chinese to send someone here to learn about satellite meteorology and everything? Oh, great idea. So he wrote up not only one letter, but I guess a small packet of a whole bunch of information. I had a whole envelope full of stuff. And I put it in my briefcase, went down there, and I got up in front of that great, big, huge building, which hadn't been occupied for quite a long time. Went up, and it was about 9 o'clock in the morning, I guess, and I banged on the door, and there was no response for a while. And then I banged some more, and pretty soon somebody came up to the door, hollered at me through the door, what do you want? So I said, I want to talk to you about meteorology and offer you some opportunities. And he said, okay, wait a minute. He went away. Oh, maybe 5 minutes later, here come two guys with guns, and two other guys. The guards stood back, and they opened the door about that far, and they said, what do you want? So I told them where I was from, and that Professor Suomi and all this kind of stuff, and the World Meteorological Organization, used all the big words I could try to think of to convince them that I was legitimate, and handed them this package and everything, which is the invitation, and said, please, we would like to establish good relationships with your meteorologists so that we can learn about how to coordinate with satellite meteorology. Oh, we will get in touch. Close the door. 3 months later, we had not had time to coordinate with the State Department before I went down there. But meantime, after I got back, I mentioned to Vern that it'd be about a really good time to go through the university and try to tell the State Department that we'd at least made an initial contact. So we did that. 3 months later, we got a letter coming down through State Department channels this time, saying that there would be a delegation of Chinese meteorologists and scientists visiting SSEC. And from the time they arrived, which was another several weeks, for many years, I don't know, we may still have some Chinese representatives at SICC. But we had meteorologists, programmers, engineers, technicians, everybody there learning about Machinas, learning about the satellites, and the result was the rebirth, the growth of the meteorological system in China and their Chinese meteorological satellite, which is now part of the whole constellation, and really, I think, continuing good relationships as far as I know.
Oh, yeah.
And we gave, they came over, learned all about Machinas and wanted us to build them one. Well, by that time they had progressed in the design to the point where it was now based on a little IBM computer. Getting the permission to ship that to China through the State Department took a long time. Finally we got permission and shipped that, and it was followed, I think, by 2 more units. But that's the basis, really, for the whole Chinese meteorological system is Machinas, their whole data system.
We just touched upon a contentious issue, and that is whether you privatize meteorological information or you make it available to the public at large.
Yeah.
And of course, in the World Meteorological Organization, that has been a contentious issue because in Europe and many countries that have meteorology organizations, they have always kept certain classes of information in their own domain, and then it's not freely available to the rest of the world. And so that has been a problem in the World Meteorological Organization to get over that. I just put 2 and 2 together here. I think very likely Suomi's resistance to privatize it may well have been a factor here.
It changed a lot of the attitudes in the World Data Centers too. Access to the data centers became more and more and more open and available globally to any country. Whereas before, there had been very severe restrictions when I first became associated with it. And we gradually worked and worked and worked and got those down. A lot of help from the World Meteorological Organization in breaking down these barriers.
Yeah.
New Zealand's one of the worst.
There are still some bad ones.
Yeah. And I kind of wanted to not give the data, let the data be sent to people that were wanting to be paid for their data.
Yeah.
But that wasn't going to win anything, was it?
No,
Nope, you give them the data.
I know for the first GARP global experiment, we wanted the data from the Japanese geosynchronous orbit satellite, the Himawara. And I was sent over there with $15,000 from the National Science Foundation to buy 1 year's worth of tapes of data. We got over there, I found that all of the data, 2 days after it's collected, it becomes the property of the retired scientists at the Japanese Meteorological Society. They own it and they can sell it if they want to. And it took about 3 days of negotiating with them and with the technicians and everything, and we finally got an agreement. My $15,000 was just enough to buy the tapes. The Japanese scientists, and the technicians, and the retired scientists all voluntarily donated their time and their data to give the complete year's worth of data to the GARP Global Experiment, which I thought was a very generous thing for them to do and a great change in the way they were set up. But that happened all over the world. It's good.
Gentlemen, I think we're sort of running towards the end here. What I would like to do is just sort of go around the table and get everybody a couple minutes to reflect on anything they would like to say about how Verner Suomi influenced their lives and their careers and their outlook on the world. And then I think we'll wind this thing up. So can we start with you, Bill? Take 2-3 minutes and give us any reflections you might have on the impact that Verner had on your life.
Well, obviously, Verner Suomi had a great impact on all of our lives sitting around the table, and those of many, many people around the world professionally. And of course, his innovations are responsible for better livelihood of all of us in the world in terms of his contributions to prediction of severe storms and things like that with his space gadgetry. As we said, he was tremendously educational. He was amusing. He had quotes that when he would make a statement, they don't go away. They stick with you forever. I gave an example earlier about the principle of pressure broadening and what an impact it had on my life of atmospheric remote sensing, understanding that principle. He had another one which I want to mention because I think it was ingenious. It has to do with assimilating satellite radiance data into numerical prediction models. It's a practice that's done today, and but before it was even attempted, and it had to do with the satellite sounding radiances. He says trying to retrieve atmospheric soundings from satellite radiance measurements is like trying to separate the yolk from the white of a scrambled egg. He says, how can it be done? He says, simple. You feed the egg back to the chicken. and it was a one-liner, a quote,
Yep.
but you never forget it, and it had made a lot of sense.
Yeah.
And it was things like that that had tremendous impact on all of our lives. And I think what I remember most about Vern, it sticks in my mind, is when he was dying. And I remember asking him, I said, he had the choice of going on dialysis or essentially terminating his life. And I pleaded with him. I said, why don't you go on dialysis? You have so much to give yet. And he said, Bill, he says, I've lived a wonderful life. He says, I have no regrets. He says, it's time for me to pass on. He says, don't feel sorry for me. He says, I'm fortunate. He says, I've got time to talk to all the people I've interacted with over the years and give them my last thoughts and thank them for what they've done and so on. And that's what he did during his last few days of life. And so most of all, Verner Suomi taught me not only how to live and professionally, but also how to die.
Well, yeah, in my case, again, the life lessons that you learn from Vern stay with you for a long time. And the many thousands of people he encountered, and we've just talked about all of his international activities and others, he kind of boiled it down one day for me and said, there's a big difference between leadership and headship. He said, there are a lot of people that are head of something, but they're really not leaders. And the attributes of leadership include creating opportunities for others. And that's something that I've, really tried to practice. And I always remember Vern when I run into that situation, when you're looking at a situation like that. The other thing he told me, in the mid-'70s, when I became a candidate for the department head or department chairman out at our university, our atmospheric science program, I remember driving with Vern in the rain. He had a seminar in Blacksburg, Virginia, and we were driving through the rain one night to get to this seminar, and something going on. And finally, out of the blue, he just said, well, Vonderhaar, now that you're stupid enough to be considering that position, I want to tell you what you really have to do. And I said, what's that? And he said, well, they're only going to remember one thing, that the good faculty that you find and hire and help mentor and I think that was characteristic of Vern because he created so many opportunities for others, including those of us around the table. And he'd reach out. He'd reach out into the Air Force. He'd reach out internationally. But he was always creating opportunities. And I've tried to do a lot of that too.
Chuck?
Well, I left Suomi's area about 2 years after, about 1959. And I just went on my own way. and wasn't influenced by them anymore. So I don't have that influence. But on the other hand, I have set up a program of automatic weather stations in Antarctica. I've equipped the last continent for weather stations at the surface. Nobody will ever do it again. There are no more continents that are open. That was the last one. My data has gone out to every one of them. I have worked with, I think, 5 or 6 nations on this, and a whole lot of people, and I have a whole organization going that's working on automatic weather station data in Antarctica. And we also are collecting the data from the satellites and giving it to people. We don't charge them for anything. And we have a vast the supply of data at home in our office. It's on the 8th floor. I don't know which floor it is, 9th floor. At any rate, I have a question for Tom, though. This is my weather station, but I would like to know, Tom, how, that's yours. Oh,
I want to look at it, yeah.
okay. I'd like to know how you process the data from the
Suomi's.
Suomi's number 7, yeah.
Well, let's see, we processed it every 30 seconds, satellites moving 7 kilometers per second. Satellite saw a view about the size of the state of Texas, plus outside things.
Yeah.
So we'd probably just get a couple of observations as we passed over Antarctica
Yeah.
in those days, yeah. And Chuck's got a network here with, looks like about 20 stations scattered.
Oh, there's about 60 of them.
Oh, 60 of them.
They're not all on
Yeah.
there.
So those were the early views. Very smooth, very exciting, but lacking in the detail that eventually we need.
How did you calibrate them?
Well, we used the direct sun as a constant source. We used the sun.
Okay, and that gave you everything.
Not
just
everything.
about. Just about.
Yeah,
Just
it
about.
gave us some early
But I
results.
knew that when it went into orbit, we had no idea what it was going to measure.
There was an awful lot of afterwards
Yeah,
processing
yeah,
by a lot of people, yeah.
Thank you, Chuck.
Yeah.
Appreciate it. Let's move down to Larry. Larry?
Well, Suomi for me was like a tipping point. I could have gone one way and had a different life, and because of him, I had a completely different life from what I might have had. He set me on an exploration of the universe, of the solar system at least, that I had no idea I'd ever even begin. So I certainly was profoundly affected by getting involved with him. When I first interviewed for a job with him, I read the kinds of research papers that were being produced, and I realized I had no experience in this area at all. I thought I could probably contribute nothing to it. And I told him that, and he said, "Don't be so narrow-minded." And that's a good point to remember with him. Don't be narrow-minded. He was bold. He was memorable. He had a way of making you remember a point. He had dramatic actions that he took or dramatic statements that he made, and they somehow seared into your memory so you'd never forget them. I wish I could remember them all. He was obsessed. He thought about all of the things he needed to do or wanted to do all the time. He kept waking up in the middle of the night. He always told me he couldn't sleep because of this idea or that idea. He was really obsessed and constantly thinking and planning and generating ideas, many of them not very good ideas, but a few were beautiful, wonderful ideas. In football parlance, he never took a play off. He was always at it. And I guess one of the inspiring things about him is he always would take a risk to try to do something unusual. So swallow your bravery pills and try something new, I guess, is the message he gave to me.
Thank you, Larry. Don?
I became a colleague of Suomi through being a faculty member of the department, although I came here out of the Air Force to go to graduate school. But my major professor was Lyle Horn, and during that time I did work on some of Suomi's innovations, but on a different purpose, and this is a radiometer called Netflix. We put on a balloon and measure the upward and downward radiation, infrared radiation at nighttime. And so, you know, this happened, and he was aware of it. There was a fellow by the name of Pete Kuhn, who was a scientist from the Weather Bureau who worked with him closely on that. And I got involved with Pete and indirectly with Suomi. My real link to Suomi happened after or during, while I was chairman of the department for 3 years. And during that period, apart from his taking Tom Whitaker from me, but no, that was with his blessing. This is beautiful. He asked me afterwards, well, you know, how about coming and be an associate director? Because we did have a good relationship, Tom here, and getting the Mercatus meteorological satellite information on the WHA 21. And I said, yeah, that's interesting, you know. You don't tell me what to do, and I won't tell you what to do. And that's where we started. And that was a very successful relationship until he actually passed on, because I too visited Suomi at those last days when he refused to actually have dialysis, and he asked me to do several things. But we had a common heritage in some sense, a value system being both Lutherans, and we didn't dwell on that, but there was a value system that we really appreciated. He served on the Lutheran campus ministry, I served on it, and as he retired and I retired, we would go to lunch once or twice a week. But as he was on that last days, he asked me to say a prayer with him, a childhood prayer with him. And that, besides contacting the people that he wanted to talk to, that was my last live association with him, which I valued dearly. He just lived life as passing on with another day in the normal lifetime of an individual. And he just had that beautiful view of everybody and relationships. Only wrote one paper with him jointly, but it had to do with Neptune, why the winds are so strong and we only get 1/900th the energy. But that's because I had interests in the way circulation is created, and why he had come and said, you know, are there any means by which we can explain why that happens? And we had a great relationship.
Thank you, Don. Tom?
Well, there are two things I would like to say about my overall feelings about Vern. First of all, when I joined, I was going to be the executive director, and the executive director's job is to manage an organization smoothly, evenly, calmly, and keep it funded well and all that sort of thing. Well, that wasn't Suomi's idea at all. So I was frequently rather frustrated, like I would get a phone call and say, Suomi's on the 4th floor doing it again. Now the 4th floor was where all the technicians were busy building Mercatus systems and doing other kinds of things where a systematic approach is really essential to get something out the door. Well, and I would have something all set up and something moving smoothly, and it was funded and everything was going fine. Suomi would get in there, he'd get bored with whatever was going on up in his office, get down the 4th floor, and he would immediately start giving directions to every technician in the place. Totally different, don't do this, do this, do this, do that. Creating total confusion and chaos. Well, this upset me greatly at first, 2-3 times. And then I saw the results of it afterwards, was that there were new ideas coming out of the technicians that they would not have had if he hadn't been in there stirring them up. And I began to realize, my God, this is management by chaos, only it's a different kind of management than anything I'd ever seen before. Well, it didn't always work. Sometimes the chaos just persisted and you had to go in and straighten it all out again. But sometimes you got really good things out of it. So I learned to live with it. The other thing about Vern was that his influence on the programs like the global experimental programs, GARP and global, all these things, had an influence which was so pervasive and lasted for such a long time that the shape of the world meteorological system, where there's a free exchange of data all over the world on a good, equitable basis and to the benefit of everyone in the world, he contributed a great deal to that. And that I remember about him too.
Thank you, Tom. I liked Larry's expression of a tipping point to describe my own situation, because I don't know where I would have gone or what I would have done upon retiring from the Air Force if I hadn't have come here and had 20 good years. But it's the first day I remember the most, that struck me the most about Suomi. I shared a little of this at the luncheon with some of you people. The first day after we had the morning staff meeting and stuff, or what I thought was a staff meeting, which in my opinion was an extremely poor staff meeting, I asked him, I said, how do I get oriented? Where do I go to look at the 3-year plan or the 5-year plan? Where do I find the organizational structure starts? And he stopped, and he sort of looked at me and he says, Bob, he says, one thing you got to understand, he says, we don't have any of those things here. Your job is to go where I want to go, when I want to go there, with all the resources that I need. That's your job. And so I staggered in the office and tried to put this in some sort of context, thinking, my God, what have I got myself into? You know? And as I'm sitting there, this head pokes in the door, and it was Vern. He looks at me and he says, I forgot. He says, another thing we never do around here is criticize anybody. He says, you can praise them lavishly or you can praise them a little, but he says, even when they screw up, we praise them. He says, you get far more by praise than you ever will by criticism. And of course, he's talking to a 24-year military veteran who may have once or twice criticized somebody in his career. And so I sat there and had a little moment of truth while I tried to decide what this second career was about to be like. But it was 20 good years, and I don't regret a day of it. I would like to take this opportunity then to thank each and every member of the panel here. I would like to reiterate that this has been an oral history recording of remembering Verner Edward Suomi, the father of satellite meteorology, made on November 2nd, 2009. Thank you, Larry. I got it right this time. At the Monona Terrace Center, I would also like to thank our camera and recording crews and everybody else who participated, and specifically Gene Phillips for organizing this entire affair. And as far as I'm concerned, that's my cut. You can all say whatever you want now.
Thank you, Bob.
Thank you, Bob. And Gene.